Hello students, in this video I will be discussing some problems on convolution sum. This is a problem given. It says a discrete time system, LTI system, has an impulse response h of n as shown in figure. Using linearity and time invariance property, determine the system output y of n if the system x of n is equal to u of n minus u of n minus 3. So in the previous video, we derived the convolution sum derivation, and the properties of convolution sum has been derived with the proof. So here we have to find the system output y of n given h of n, that is the impulse response they have given. That means this diagram, you can see this. So this is given. This x of n is not given, they have just expressed x of n is equal to u of n minus u of n minus 3. Now to solve this, we require two signals. One is given, another one we have to plot by ourselves. Okay, so let's start solving this problem. So since h of n is given, so we have to plot first x of n and then we have to convolve this. This method particularly uses a graphical method. So we call this as graphical method of solving the problem. So let's see how it works. First we plot x of n. So let's start solving this. So what is x of n is given? X of n is equal to u of n minus u of n minus 3. So now u of n is unit step function. So let's plot this first. So from the definition of u of n, so this is what you know this. So u of n will be 1 for n greater than or equal to 0. So please mention the signals, and the amplitude will be 1 here. It varies with respect to time n. Now u of n minus 3, I am just writing one below the other. We want minus u of n minus 3. First plot, we plot u of n minus 3 here. So I am trying to plot u of n minus 3. So that means we have to shift the signal u of n 3 times. Since it is n minus 3, we have to shift towards right here. So right shift the same signal 3 times. The signal starts from 3 here. So 1, 2, 3, 4, 5, 6, etc. So this is how the signal look. This is the time shifted version u of n minus 3 with amplitude 1 here. Next we want minus u of n minus 3. So I will be plotting this here itself, right next to that signal. So minus u of n minus 3 means then the signal will look like minus u of n minus 3. The amplitude of the signal will change to plus 1 will become minus 1, and the signal starts from 3 only. So the signal will look like this. The amplitude will be minus 1. The signal starts with same at 3 only. So this is minus u of n minus 3, and this one, this is u of n, and this one is u of minus u of n minus 3. Now we have to add these two to get our x of n. Just to perform that addition, I am just writing the signal one below the other. So first I will write u of n, which starts with 0 with amplitude 1, and next u of n minus 3. I forgot to write the u of n minus 3, 1, 2, 3. This is 1, 2, 3, 4, 5, 6, etc. So this is minus u of n minus 3. Okay, I'll write this once again. Minus u of n minus 3. Now we have to add these two. As you can see, at 0 we have 1 here, and 1 at 1 we have 1, and at 2 we have a signal with amplitude 1. At 3 we have 1 here, and at 3 we have minus 1. So the amplitude for the signal is minus 1. So plus 1 and minus 1 0, and here plus 1 minus 1 0, plus 1 minus 1 0. So after 3 the entire signal will be 0 here. So the signal here from 0 at 1, 0, 1 and 2, if you perform addition, then the signal will look like this. So this is u of n minus u of n minus 3, or you can simply write this as x of n. So at 0, I'm just showing this, 1 plus 0 is 1. At 1, 1 plus 0, again it is 1. And at 2, 1 plus 0, again it is 1. And at 3, here it is plus 1, and here it is minus 1, so that is 0. And at 4, plus 1 minus 1, 0. And at 5, so as it will be having the same amplitude with respect to n, here also 0, 0, and the signal will go on like this. So this is our x of n. Now we have to convolve these two. So this signal is x of n. Just for simplicity, I will rewrite the same signal here. So x of n will be present only at 0, 1 and 2. The same signal I have just written just for simplicity, for my convenience. Now observe, x of n is having only 3 samples. So go to this one, h of n. So this one is having 1, 2, 3, 4, 5 samples. Okay. Now when you are performing convolution using graphical method, you have to, from the definition of convolution sum, what does it say? Y of n is equal to, since we have to derive the system output y of n, determine that. So I am using the expression of convolution sum y of n is equal to x of n convolved with h of n. Now you have to observe one thing here. So x of n convolved with h of n means we have two functions here. One we can keep it as constant, and another one will be the time shifted one. So if from commutative property I can go with x of n convolved with h of n, or you can go with h of n convolved with h of n. So whichever you are taking in the expression, you are writing as n minus k. So that will be the time shifted signal, and another one will be kept constant. Okay. So I am repeating once again, if whatever the signal, this one, you can see this summation k is equal to minus infinity to plus infinity x of k h of n minus k. So the one among these two signals, the one which is having h of n minus k, so that will be the time shifting signal, and another one will be the constant one. Okay. Now you have to decide which signal you want to keep it as a constant one, and which signal should be the time shifting one. So each time shifting signal will be multiplied with the constant values, whole signal x of n, and the resultant will be written. In this, while dealing with the graphical method, I suggest you consider the signal which is having less samples as the constant one, sorry, as a time shifting one. The signal which is having more samples, consider it as a static one. Okay, that means comparing x of n and h of n, x of n has 3 samples, okay, and h of n has more number of samples. So, better the signal which is having less samples, to keep that as a constant one. The signal which is having more samples, you just keep that as a time shifting one. Okay. So, then we will solve the problem. Consider the two signals. I am just rewriting h of n here. So, h of n signal varies from -1 to +3. At -1 we have 1 as amplitude, and at 0 it is 3, 2, -1 and +1. So, 0, 1, 2, 3. So, this is h of n. Here x of n. Okay. So, now let us start solving this. I will take one signal, one sample at a time, and that will be multiplied x of n, one sample at a time, and this will be multiplied with entire h of n. Now, I have considered x of n convolved with h of n. So, whenever I am taking the signal, the one which is at the origin, there will be no shifting for h of n. If you take the next sample, that is 1, then this h of n, the entire signal will be, the time shifted will be shifted towards right one time, because I am taking the signal after the origin. So, this one, when the second signal, when I will take the second sample, the entire signal h of n must be shifted twice, shifted right two times, then it will be multiplied with the amplitude of the signal, the entire signal, and the resultant will be obtained. Now, each time when you perform this action, you will get different signals, 3 different signals, and at last we have to add all of them to get the end result. Let us take one by one here. Now, first I will take the signal of x of n, which is at the origin. Okay, so at origin we have the sample with amplitude 1. So, this is origin. There is no shifting in h of n. So, the signal will remains as it is. So, it varies from -1, 0, 1, 2, 3, this one, and here it is 3, 2, -1, +1, 1, -1, 2, 3. So, what you get here is the output. I will call this as y1 of n. So, the amplitude of the signal is 1, multiply with all the samples with the amplitude of this signal. So, at -1, 1 into 1 is 1 here, and at 0, 1 into 3, 3 here, and at 1, 1 into 2, 2 here, and at 2, 1 into -1, you will get -1 here, and at time index 3, 1 into 1, you will get 1. So, this is y1 of n. Now, I will take the next sample of x of n, which is at time index 1. Since it is one place right side towards from the origin, now this h of n should be right shifted one time, and then it will be multiplied with the sample that is present in x of n. So now we are going to shift this. The h of n will be time shifted. Since it is shifted once, the signal starts from 0, 1, 2, 3, 4. One time I have shifted towards right. Now the amplitude at 0 will be 1, at 1 it will be 3, and at 2 it will be 2, and at 3 the amplitude will be -1, and at 4 the amplitude will be +1. Now multiply this with the entire h of n with the sample present at x of n. Okay. So the signal now starts from 0, 1, 2, 3, 4. Okay. So at 1 into 1 is 1 here, and 1 into 3 is 3, 1 into 2, 2, -1, and at 4 we have +1. So this is the second signal, and now I am taking the third sample of x of n, that is at time index 2. The amplitude of the signal is 1. Since it is located 2 times from the origin towards right, then we have to shift h of n 2 times towards right, and then we are going to multiply this with x of n. Now when it is shifted, the signal will start from 1 and it ends at 5. So at 1, you observe this, at 1 we have amplitude 1 here, and at 2 we have amplitude 3, and at 3 we have amplitude 2, and at 4 we have amplitude -1, and at 5 we have amplitude 1. Now when this get multiplies with the signal, so let's see what happens to this. And I forgot to mention this signal, I'll call this as y2 of n. Okay. So now at 0 nothing will be there, and at 1, 1 into 1, 1, and at 2, 1 into 3, 3, and at 3, 1 into 2, 2, and at 4, -1, and at 5, +1. Okay. So now observe this, we have y1, y2, y2 of n, and this will be y3 of n. All three samples has been taken individually and it is multiplied with h of n. You can reverse the process. If you want, take each sample of h of n and multiply with the entire signal x of n, then you can go h of n convolved with x of n. That means you will get 5 signals that time, y1, y2, y3, y4, y5, and you have to perform addition of all those 5 signals. But if you take the lesser symbol x of n, h of convolved with h of n, 3 samples one at a time, and that will be multiplied with entire h of n. So here we have to perform addition only 3 times. So that is the difference. So you have to choose whether you have to go for x of n convolved with h of n, or whether you have to go for h of n convolved with x of n by looking at the signals. Okay. So always try to keep one which is having less samples as a static one, more samples as a time shifting one. Now we have to add these three signals, y1 of n, y2 of n, and y3 of n, to get the final output y of n. Now see how it will look like. This signal is starting from -1 and +3, and in y2 of n we don't have any signal here, and at -1, and at just for more clarity I am mentioning that -1 as well. As you can see, in both the case it is 0. Now let's perform addition. I am writing the final output y of n here. So the signal starts from -1, and let's see where it ends. Okay, -1. Now see this, at -1, 1 is there, 1 plus 0 plus 0, that is 1 itself at -1. And at origin, we have 3 plus 1, 4 plus 0. So 3 plus 1 is 4. The amplitude of the signal is 4 at the origin. So we are plotting y of n, the final output here. Now coming at index 1, we have 2. Here we have 3. 2 plus 3 is 5. And again at 1, we have the signal with amplitude 1. 2 plus 3, 5. 5 plus 1 is 6. So let's plot that graphically. The amplitude at 1 is 6. Now go for index 2. Here at y1 of n it is -1. At y2 of n it is +2. So 2 minus 1 plus 2 you will get 1 itself. And at y3 of n we have 3. So -1 plus 2 plus 3. So that will give you -1 plus 2 is +1 plus 3 is 4. So at 2 we have a signal with amplitude 4. Now coming to index 3, 1, and here -1, 0, 1 -1 0, and here we have a signal with amplitude 2. 0 plus 2 is 2. Okay. Next go to index 4. Here at 4 we would have nothing, 0. Here we have 1. 0 plus 1 is 1, and plus 1 minus 1, 0. So at 4 the signal is 0. Coming to signal 5. Here we have 0 at 5. Here also we have 0 at 5. No signal here. And here we have 1. So 0 plus 0 plus 1 you will get 1. So this is our final plot y of n, and we can also represent in this way. Y of n is equal to 1, 4, 6, 4, the amplitudes 1, 4, 6, 4, 2, 0, 1, and the origin is this one. Now since what we get as an answer y of n, how to confirm or how to verify whether what we have done it is right or wrong. So there should be a verification process required for this, and apart from that, here you can see whatever the time index that we got. So the signal varying from -1 to +5, whether it is correct or not. So to make this, we have a small verification process. First one is checking the index -1 to +5. Is it right or wrong? For that, we have a small formula, that is L is equal to m plus n minus 1. So this is the way small thing where L represents length of y of n, that is our end signal. What about m? M will be length of x of n, and n will be the length of the second signal. So we have two signals, two functions. M represents length of first signal, n takes the length of second signal. Okay. So here in this case we have x of n and h of n. I am writing x of n and h of n. And sometimes the signal will be like x1 of n and x2 of n. You can consider that accordingly. But m represents signal of first signal, length of first signal, n represents length of a second signal, like that. Now when you look at the signals here, x of 1 is having 3 samples and h of n is having 5 samples. Now we substitute that. So that is m is equal to 3 here and n is equal to 5. Then what happens to L? L is equal to 3 plus 5 minus 1. That is 3 plus 5 is 8 minus 1, that will give you 7. That means the length of y of n should be 7 samples. Let us count this 1, 2, 3, 4, 5, 6, 7. So according to this we have 7 samples present in that. Now so the second thing is this indexes. What about the indexes? For that, to indexes you can go like this. Starting index of x of n plus starting index of h of n. So if you add this, you will get what? Starting index of y of n. Okay, you can rearrange the expression like this. The same applies to the end index as well. Now the starting index of y of n we are going to look. So what is the starting index of x of n? Look at the signal. X of n is starting from 0 and h of n is starting from where? Minus 1. So let us add these two. Starting index of x of n is 0 and starting index of h of n is minus 1. If you add these two, the starting index of y of n you will get as minus 1 itself. Now the same way, end index of y of n can be determined like this. End index of x of n plus end index of h of n. So if you look at the signal, the end index here is 2 in case of x of n and it is 3 in case of h of n. So let us add that. 2 plus 3, that is equal to 5. So that is end index of y of n. So the starting index of y of n should be minus 1 and end index of y of n should be 5. So all these are for your verification. If you look at the signal of y of n, the end plot, it is starting from minus 1 and ending at plus 5. So you have two things to confirm. First one, y of n should have 7 samples based on the length. We have 7 samples here and the signal should start from minus 1 and it should end at plus 5. So the same thing we are getting here, minus 1 and plus 5. So this is the confirmation that we got the index right and we got the number of samples right. Okay, and the last thing, there is another final way of confirmation, that is verification, whether what you have got this answer 1464201 201, whether it is right or wrong, because you can see this while adding the signal you might miss some of them, that if you are not written one below the other, if you have written somewhere else and if you are performing addition, you might miss one, you might do some mistake in the addition process. To avoid that as well, you can also verify the signals like this method. In this method, just write the signals x of n and h of n. You can do this vice versa. What are the samples present in x of n? That is 1 1 1. Okay. Now what are the samples present in h of n? It is starting from, you just write it horizontally. I'll just take this. The values are 1, 3, 2, minus 1 and plus 1. 1, 3, 2, minus 1 and plus 1. Now perform multiplication here. 1 into 1, 1, 3, 2, minus 1, plus 1. Again 1, 3, 2, minus 1, plus 1. I am just multiplying this. 1 from this all the signal, and from this all signal, and this again all signal. Whatever the sample you have, you just multiply with that. Now this part is, you draw line like this. Diagonally combine the signals, all of them. Now you take one, the first one right here, 1 is there. So this is y of n, 1 is there. Next, if two more than one signals are there, you add them. 3 plus 1 will get 4, and here 3 plus 2 plus 1, that is 6, I guess. And here 3 plus 2 5, 5 minus 1 is 4. Next 2 minus 1 is 1, and 1 plus 1 is 2, minus 1 plus 1 is 0. Last you will end up with 1. Now the signal, as we have clarified, it will start from minus 1 and it will end at plus 5, minus 1, 0, 1, 2, 3, 4. So you can put the, so this is the verification process, and you can check that I think we have got the same value 1464201. Here also we have written 1464201. The signal starting from minus 1 to plus 5. Now from here, whatever I written here, so this is for your verification. So in the examination, you can go check whether you have done the problem correct in way or not by using these verification procedures. Okay, this is not mandatory. This is just for your verification purpose only. And I hope you have understood the problem. If you have any kind of doubt at any point, please you can call me. You can have my number, you can mail me or text me. I will get back to you. Okay. Hope this method you will I hope you have understood the way of solving the problem, and we'll take some examples on this. And I'm just giving one more thing for you to try. Try this, and if you won't get the answer, you please do inform me. Don't forget to inform that. I'm giving two samples here. Take the same h of n. This is just for another problem for you to verify. Take the same h of n sample, the same thing. H of n is equal to plus 1, 3, 2, 0, sorry, not 0, minus 1 and 1, I guess, as 5 samples, signal starting from here. And for x of n, I give you a simple one, that is 2 into delta n minus delta n minus 1. So this signal is for your homework. That means try this one. If you find any difficulties solving the problem, please inform me. I will clarify your doubts. Okay. Thank you.